the selection criteria. Okay, and these are the already discussed in the first chapter. There is a introduction part. This is chapter 1. Chapter 2, that is measurement of the, that is a pressure sensors, force sensors. Okay, measure sensors and force sensors, or weight force and weight sensors is almost same. Okay, so pressure sensor and force sensor. So under pressure sensors, that the topics that already discussed, manometers, bellows, rotative diaphragms. Okay, so there are three types of manometers under the manometer. One is that one is that YouTube manometers, inverted bell type manometers, ring balance type manometers, and inclined manometers. Okay, and the single limb and double limb concept. That's all about the manometer. That thing already discussed, and problems already I've shared with you, and I've shown some 2 examples on the manometers. And next one is that bellows, that one is the working principle, within discuss construction, disadvantage, advantage, bottom tube, diaphragm, elastic sensors. Basically bellows, bottom tube, diaphragm is the elastic sensors. That thing already discussed. Next is the force sensors. Under force sensors, basically there is a strain gauge, that is a discussed. Strain gauge is basic construction and workings, bridge configurations, and 2-3 numericals that already shown, exercise examples or based on strain gauge. That is a signal condition, based on the signal conditioning method. That is half bridge, quarter bridge, and full bridge methods. That is very important. Okay, so that thing already discussed is very important. And weight sensor, basically nothing but a load cell. But suppose what is a strain? Strain means suppose I apply some force or pressure. So load cell means it's suppose suppose we put some weight on the on the strain. Okay, so that is the load cell. Load is different kinds of load. Whatever you doing in the actually that you have done in the practicals, you have performed in the practical. That is a different types kinds of loads. Suppose if you are giving suppose what would be the effect of the the strain and whatever. Okay, so accordingly that you have to calculate the output voltage as well. That thing actually. Okay, so that is actually loads. So different kind of loads that you have to apply. Then accordingly that you have to calculate the voltage. That is actually what force and load cells. Okay, load cell is nothing but a that's weight sensor. Okay, so that thing already discussed for strain gauge in details. And next thing that temperature measurements. Under temperature measurements, that is the first thing. There's a mechanical thermometers. That is a very common. That's I have not discussed, and it's not much important. Normal thermometer. There's a normal thermometer. Okay, the field in the system, metallic expansion. So that thing I have not discussed. Okay, so it is not required. So main thing is that electrical thermometers. So that thing I have discussed, electrical thermometer. That is RTD, thermocouple, and thermistors. Parameter actually it is not in your course. Parameters, okay. Parameter is not in your course, but I have shared study materials, so you can go through the parameters, basic working. So it is available in that materials. Parameters is basic concept I have given you because you know that. What is the parameters? Parameters basically it is used for the high temperature measurements. Basically the RTD, thermocouple, thermistors. Basically. It is a contact device, right? That is a direct type several sensors. A radiation parameter, optical parameter, that's the indirect type, means contactless. Basically, parameter it is used to radiation parameter and optical parameter. It is a furnace, okay, blast furnace, okay, in a plant. So where RTD, thermocouple, thermistors fails to operate it, okay. So measure the temperatures because the furnace temperature is more than 3,500 degrees Celsius or whatever, or above than 3,000, between the 3,000 to 400 degree, 4,000 degrees Celsius. Okay, so in that case, parameter is used indirectly, okay, and through the optical radiations. Okay, so you can go through that in basic workings for your knowledge that it is available in study materials, but it is not in your course. Okay, the radiation parameters. So only RTD, thermocouple, thermistors available, and based on the thermocouple, thermistors RTD that I have shown that one on examples each from each temperature sensors. That is very important. How to calculate output voltages, temperatures using the formulas that I have already shown, 2-3 numericals from this temperature sensors. Next one is the displacement sensors. There is a displacement sensors. Okay, there is a chapter 4 actually. Chapter 3 actually temperature measurements. Chapter 4 covers displacement and velocity measurements. Okay, so this is chapter 3 and chapter 4. That's a combined actually. Okay, So chapter 4, that is displacement sensors. That is the inductive type. One is the inductive type. That is the example is LVDT, RVDT. So that is a inductive type sensors. Proximity inductive type displacement sensors. LVDT are basic workings principle. And I have shown one to MCQ type objective type 2 mark question types problems from LVDT. That's very important. And next is the capacity displacement transducers, capacitor displacement transducers. Okay, so that is a differential arrangement, that what I've explained in the differential arrangement is very, very important in the differential arrangement. So based on the you can face in the derivation in exam or derivation based questions or numerical based questions. Okay, so that derivation derivation potentiometer with loads just potentiometer cell. What is the concept of potentiometer cell? That is the EMF, unknown EMF, how to measure, known if known EMF, if it is given to you, then unknown EMF, how to measure. There is a basic concept that that is you are given in the in the lab, in the control installation lab. So based on that, you have performed the experiments, and you have calculated the displacement factors also. That is very important. So up to that, you have performed. But main thing is that in this case, in this course that I have added here, the potentiometer with loading effect and potentiometer without the loading effect. That is a very important part. Okay, means how to calculate the errors, the absolute errors and the relative errors. Okay, between that. So because in the ideal condition, that potentiometer basically that is a it will be showing the linear curve, but in the case of the practical case, it will be showing a non-linear, right? So that error could be determined. So that thing you have performed that yesterday through the numericals also. So the problem is very important. This type of problem you may face in exam. So that's why I have stated that problems. Okay, and I have shared with you yesterday. So potentiometer with loading effect without loading effect is very important. So you have to calculate first true value, and then you have true value means potentiometer without loading effect, and absolute value about measured value you have to calculate potentiometer with loading effect, right? So that thing you have to calculate measured value minus true value by true value. Okay, so that schematic diagram, schematic arrangement is very, very important. Okay, so for each sensors that were discussed, the diagram is very important. Okay, suppose if any questions comes to you, first try to try to draw the schematic diagram, not diagram, whatever. Okay, because it will carry 1 mark or 2 marks. So diagram is very, very important. If it is even not mentioned, so you have to draw it. Okay, so diagram is very important. Without it that we will not add the marks. Okay, so that is simple, right? So that is about displacement sensor, inductive capacitive and potentiometer. Next thing is that position sensors. Position sensors basically that we have that discussed are the proximity sensors. Proximity sensors that we have discussed. What different types of proximity sensors? Capacitive type proximity sensors, inductive type proximity sensors. Okay, and optical type proximity sensors also have discussed. Okay, so that thing we have discussed already. And next thing that optical encoder is not important. Basically it is a digital waste. Okay, so I will give you just in the basic concept in the next class what is the optical encoders. Okay, and that's is not too much important. Okay, and next is the velocity measurements, and the velocity measurements is that that we have discussed, very important. Tachometers, it basically tacho generator, actually tachometer generators is an DC type tacho generators. What is the difference between the tachometer and a tacho generator? Explain the working of basic constructions workings, and I will give you the study materials also of tacho generator in the Google Classroom. Okay, and it is available also in S-casing. You can go through S-casing. That is a tachometer portion is available also. Okay, so that is and after that is the encoder. Encoder basically is it falls under the position sensors. Okay, not velocity measurements. Okay, so that is all about. So this is the chapter 1, chapter 2, chapter 3, and chapter 4. Midsem course. Okay, so accordingly that you have to prepare. I have shared all the study materials up to inductive or capacitive transducers. So I will share the study materials on potentiometer ones and potentiometer and tacho generators. Okay, so what I have discussed in potentiometer loading effect without loading effect is that it is available also in S-casing. Okay, S-casing also, so you can go through in S-casing that part also. Okay, so it is already available in that particular discussed also in that chapters. Okay, so you can check it. So So introduction. So this is the chapters, and next chapters that are that is chapter 5 and chapter 6, level measurements and flow measurements, that will be continuing in the next class. Level measurement and flow measurements. From the flow measurements, that only that one experiment you can perform. So that is only orifice. Okay, so that is only orifice meter that you can perform. That is a typical applications. Okay, and very interesting applications. So that you only can perform. So if you able to understand that how to perform the orifice, so you will be able to perform other flow sensors like venturimeters and other nozzles, parameter, whatever. Okay, so concept is almost same. Okay, but you have to change the configurations only. So that is the main difference. Okay, that is the main thing. So under level measure, there's already that you have performed the lab experiments for each sensors individually, like from the 4 sensors you have performed. So that is a strain gauge you have performed. You have performed on the LVDT, that is the induct displacement sensors. You have performed temperature sensors, that is RTD, and performed on the thermocouples. Okay, and you have performed on capacitive. So capacitive actually that is linked with also the level, because using the you have performed there is an application using the capacitive transducers how to measure the level in a tank, in a storage tank. Okay, so basically that you have performed on experiment on level measurements. Okay, using the capacitive transducers. Okay, so that's thing you have performed. So it is the application, you consider it is an application of capacitive transducers. And next week that you will be performing the experiment from flow sensors. Okay, so I will start from the level. Sensor. So after covering the level, I will go for the flow measurements. So it will take hardly 3 to 4 classes to complete the level measurements. Okay, but for flow measurements, it will be taking for 10-12 classes, more than 10-12 classes. Okay, so then that it will go for flow measurements. Okay, so there are so many flow sensors are there. Okay, so and one thing is that if it is not covered, if we are not started the flow measurements on a Wednesday, it is not possible. So on the in the lab, that first 1 hour that I will discuss on the basic theory, that what you have to perform. Okay, so we will focus particularly on that experiment. Okay, so that's thing you have to what we have to do. Okay, so that thing we will just explain a particular day. Okay, so after that you can perform it. Okay, so when we'll start the theory part, flow sensors, so then again I will explain the in details. Okay, so what is the is working and whatever. Okay, fine. So so midsem syllabus, is that okay? So is it clear to you all? What is the midsem syllabus overview? Is it clear?
So it's still velocity measurement, right?
Yes, up to velocity measurements. Okay, up to velocity measurements. Okay, so chapter 1 introduction, chapter 2 pressure and force, chapter 3 temperature, and chapter 3 temperature, and chapter 4 displacement velocity. Understood?
Yes.
Okay, so up to that midsem midsem will start from 21st now, 20 or 21st. Your midsem starts. That yet came. So. I will try to share some numericals for practice, and some numericals also it's available. In SKSing. SKSing is the numericals available. Few numerical for you have gone
No,
through
sir.
you have
No
gone through
numericals,
temperature sensors, pressure sensors. You have checked any numerical?
Yes, the pressure sensors I checked, but there are no certain numericals.
And for LVDT, temperature sensors, RTD.
LVDT I didn't check, sir, but for pressure sensor manometer one, there are no numericals.
Okay. But those numericals that are discussed in this class, that you have understood, that you have already practiced,
Yes,
you have done, you have solved. Okay, so that is very important. That is enough. Okay, so that type of questions that you will be facing in exam. Okay, so that's why I've shared that type of numericals, and I will share the 1-2 numericals also from each sensors in Google Classroom for your practice purpose. Okay. So I'm trying to share by 10-12 September. Okay, so numericals, including all the sensors, 5 to 6 numericals for practice. So today that I will not start any topics. Next week Monday that I will start the level measurements. Okay. Fine. So midsem course clear. Hello, if I've understood the midsem course. What are the topics? Okay, so just I'm taking the attendance today and we'll end the class. Okay.